Prior to acquiring or developing new information systems, an organization should determine the security impact that the new solutions would introduce. This approach should be formalized into a process, which follows commonly known secure design principles, and relies on a well-established security model. Security should be considered at every stage of acquiring or developing a new solution, that means from the early planning stages, to the design and implementation stages, and to the post-implementation and maintenance stages. By doing so, an organization could avoid being exposed to security risks and threats, and would probably save cost by having security controls already built in, than having to add it to an existing and functioning solution. The more critical a solution is to the business, the higher the security criteria should be. There are several security principles that should be understood and implemented in order to achieve security in the engineering process of a hardware or software. The first principle is to identify the subject and object of an access request to a resource. The subject of the request is the entity that is initiating the request, which could be a user, or simply another process. The object of the request is the resource that the subject wants access to. For example, this request could be to read or copy data, to utilize a specific hardware, or to gain access to networking services. An object can be considered as a subject itself. For example, when a process receives a request to provide certain data, but then makes a request itself to another process to have access to further data that it needs. This introduces the concept of transitive trust, where the first entity trusts the second entity, and the second entity trusts a third entity, then the trust relationship extends from the first entity to the third entity. This might represent a security concern if the first entity is not allowed to have access to the third entity, however it still manages this access through the second entity. Another security principle to be considered is the open and closed systems principle. Closed systems are information systems that work with a limited number of other systems only, such as proprietary systems, while open systems are built based on open standards, and are usually easy to integrate with other systems that use the same standards. Closed systems could also have their source code hidden to the public, unlike open systems. Naturally, closed systems have a better security since vulnerabilities that affect common system components wouldn't apply in this case, and a very specific and customized attack should be performed to compromise the system. Although open systems facilitate integration between systems from different manufacturers much easier and faster, their openness makes them vulnerable to more common attacks. In addition, since a larger portion of systems are open, the number of attackers that target them is much higher than the number of attackers that target closed systems.